through some problems here that really illustrate the big ideas in chapter 7 and 8. So you're given a problem where the data shown reports the price of diamonds of different sizes in Singapore dollars. And the following table contains a data set that is consistent with this data adjusted to US dollars in 2004. Now, as I look ahead at some of the questions, I'm told to create a model to predict diamond costs. So if that's my predicted, that's my Y. And here's my X, or the explanatory variable. So if this is my X, it just is easier on my brain if I make that one L1 and this one L2. So in my graphing calculator, I've gone to Stat Edit. I've already entered my data into L1 and L2. So I'm going to get out of here. I'm going to make a scatter plot, and I'm going to run my regression model because I know I'm going to need to do those things. So the moment I run my regression model, I also remember that my residuals will be stored in the background. Okay, so I'm going to store my regression equation. Let's see. I like to store it in Y1, so I hit vars, go over to YVars, choose the first option for function, and Y1. And then I calculate. These are the things I'll need for my linear model. But first, I want to look at my scatter plot. So I've turned my plot on. I've used L1 and L2. So I'm just going to go to zoom 9 immediately. So I can see there's my linear, or my scatter plot, and I already fit my model to it. So when I go to make my scatter plot, things you need to remember are you need to put tick marks at an appropriate scale on both your X and your Y axis. You need labels, and you need a title. I'm not going to take the time to go through all that, but then you're asked to describe the association. Well, I can see here on this that I definitely have, I'm going to just write down DEFs to remind you: direction, unusual feature, form, and strength. I would say that there is a fairly strong positive linear association, and then I put it in context, between the size of diamonds in carats and the cost in US dollars. Next, I'm asked to create that model for the predicted diamond cost. So my diamond cost, and I already ran my regression model. I'm just going to go up to my history and hit enter and run it one more time. And there it is. So my diamond cost is equal to negative 558.52 plus 8225.06 times size. Okay, make sure that you don't forget your hat for the predicted diamond cost. Next, we're asked, is a linear model appropriate? And we're told to explain. So when I address this, first of all, do I have quantitative data? Sure. Okay. I looked at my scatter plot. So we would talk about, and you're going to put this into sentence form, the scatter plot was definitely fairly linear. Wouldn't hurt to say of quantitative data. The scatter plot of quantitative data is fairly linear. But I should also look at my residual plot just to make sure that I really have a good model here, or a situation where I can make a model, I should say. So I'm going to go back into stat plot. Remember, the residuals are automatically stored. So I'm still going to use the same X value for L1, but for L2, I'm going to change this to the residuals. So I go to second list, and on mine it's option 7. Your calculator, your residuals may be further down. You just have to hunt for them. And then I'm going to go to zoom 9. And I can report that there is random scatter in my residual plot with no leftover curve. So now we're asked to explain the slope of our model in context. So I'm just gonna run my regression one more time so I can see my slope. And there it was, the 8,225, and I think it's change in y over change in x. So I say, for each additional carat a diamond weighs, the predicted, make sure you use that word predicted, cost increases by about $8,225. And then we need to interpret the Y-intercept. So I think about that as a point. I think about it, it's the point 0, comma, negative $558.52. And I would say that this is a scenario where the y-intercept really doesn't make sense in the context of the problem. It's only useful for the model, but doesn't really help us in real life, because it's saying that a diamond that does not exist or weighs 0 carats is expected or predicted to cost negative $558.52. So that's what it means in the context of the model, but it's not useful in real life. What is the correlation between the cost and the size? So correlation is your R value. So a correlation, so a correlation of 0.99 indicates I would say very strong positive linear association between your two variables. Okay, so explain the meaning of r squared. So yes, it's the square of r, but this is telling us how strong our model is. This means that 98% of the variability in your y in diamond prices can be explained by the model, can be explained by the least square regression line with weights. So in other words, the size, or maybe I should say size, the size is accounting for, this model is accounting for 98% of the variability. This is a really good model. So really, that's really dictating a lot of the variation in prices, but that other 2% could be attributed to other things. Could be the cut of the diamond, the clarity of the diamond for this particular sample. I'm asked, would it be better for a customer buying a diamond to have a negative residual or a positive residual from this model? So for me, remember, a residual is your actual minus your predicted. So I personally would want a negative residual, meaning that I paid less than predicted. So I'd like a negative because paid less than predicted. The final question here. So 20 types of beef hot dogs were tested for calories and sodium. The hot dogs averaged 156.85 calories with a standard deviation of 22.64, and then we're given our sodium statistics, and we have a correlation right here. Write the equation of the least square regression line predicting sodium levels from the number of calories. Okay, so I've kind of set mine up, the predicted sodium. So calories is my explanatory. So here is my x bar, and the standard deviation of my x's is here, whereas the mean of my response is here, and this would be the standard deviation of my response, and I'm given my R value. So I need my y-intercept and I need my slope. From my formula sheet, I know that the slope is equal to r times the standard deviation of the y's divided by the standard deviation of the x's. So I'm just going to fill in 0.887 times 156 oops, I just put that in the wrong spot. That one needs to be in the denominator. Even though I labeled them, I still got them in the wrong spot. So I highly encourage you to label things in that word problem just like I did. All right, toss that in your calculator, and I get 0.579. Okay, I also need my Y-intercept, and I'm actually going to derive this, remember, from this formula on your formula sheet, where they're plugging in x bar, y bar. So that means that A is equal to y bar minus b x bar. Okay, so to get my A, I'm going to do y bar is 401.15 plus b is 0.579 times x bar is 156.85. Now, I'm going to tell you, I don't like to round multiple times, and I just rounded right there with my slope. So when I actually type this in my graphing calculator, one of my tricks is I put plus answer, my last answer, and then I'm not rounding. Just a tip. So I get A equals 492.01. I'm going to say approximately, because again, I've rounded. So as I plug this in to my model, here we go. So this is an example of how you can get your regression model from summary statistics, meaning you don't have raw data. Okay, so there's a good summary of problems that you could encounter on your next assessment. Please reach out with questions.